Hey, we're live, yet another Ask Us Anything show. Today we have a special guest, Dario. I'm going to let him introduce himself in a second. First, let me tell you what the subject is. And the subject is Kubernetes Operators. Now, as you already know from previous episodes, doesn't matter what the subject is, you can still ask anything you want. We still reserve the right to say we have no idea, but ask anything you want, especially if that something is related to Kubernetes operators. So start writing your questions right away. That's the whole show. We have not prepared anything. There is no script, nothing, only answering your questions. Now let me introduce our guest, which is Dario, not which, Dario from HAProxy, I think, Technologies, something like that. Anyways, Dario, say who you are, and then let's see whether we have any questions.
Yeah, it's a me, Dario. No, I'm from Italy, so every time I say that joke. Anyway, my name is Dario Tranchitella, and I'm working as software engineer for HAProxy Technologies, and at the same time also doing technical advisor at Classics. It's a startup based in Italy, and we are mostly working regarding multi-tenancy on Kubernetes. And we develop several operators that are solving the hard and soft multi-tenancy on Kubernetes.
Okay, you want to say something about the project on your t-shirt?
Oh, sure. This is Capsule. So Capsule has been my first open source project, and I'm really happy because starting from 2023, we reached 1K GitHub Stargazers, and it's a pretty nice milestone because it's my first open source project that I started. We are getting more and more interest about that, so I'm really proud of that. What is doing Capsule? Essentially, we are creating a sort of abstraction that is named tenant, and the tenant is a collection of namespace. So instead of creating multiple clusters, and creating multiple clusters means that you have to take care of all the clusters, so you can use just a single cluster, a huge single point of failure, but creating slices of that cluster. So essentially, it can be used by several departments, several tenants, and they got all the requirements to automate the RBAC, all the rules regarding the policies, and so on and so forth. Because when you are just using your own cluster, that's really good, because in the end, you don't need to prevent any privilege escalation because you're just going to get hacked by yourself. But if you're using a shared environment instead, you need strict requirements, strict boundaries. And Capsule is doing that, always keeping the same developer experience that you can expect on a regular Kubernetes cluster. So no need of third-party plugins on kubectl, no different API types, always the same API primitives offered by Kubernetes itself.
I'm muted. There we go. Okay, we have a new member to the channel, so welcome, Fanny. I guess that's how it's pronounced. If not, don't judge me. We have another message from Miroslav saying already 12 months passed, probably since he's a member. Thank you so much, Miroslav. For some reason, I did not get a notification here, so I cannot display it on the screen. But Miroslav, wonderful. Now, before we go into questions, and you guys and girls as well, start typing your questions as soon as possible. Dario, can you give us a quick overview? What is a Kubernetes operator? Whoa.
Sure.
Why do I care?
Well, keep in mind that I started getting more interested regarding operators because I've been a site reliability engineer in a previous company. We were doing a product based on Kubernetes. So essentially it means that we were packing our business logic into Kubernetes itself. So we were handling as a service. So it was a sort of hosting as a service. And it means that you need to create multiple resources like the ingress, the configuration, the config map, the deployment, the secret, and so on and so forth. So instead of dealing with that with Helm releases or doing that manually, we thought that we could create a sort of automation. So essentially, the operator is a way to orchestrate your domain objects, like your application, like any other external object, into Kubernetes and let Kubernetes manage that on your behalf. So it's a sort of automation because in the end, you just need to create your instance, and the operator is going to perform what is the operator pattern. So it's watching for the current state and the desired state. It detects the changes from the two desired from between the states and perform the actions on your behalf. So it's like having a sort of site-reliability engineer, but in an automated way. You can imagine ChatGPT on Kubernetes that is doing the hard work for you, something like that.
And it usually comes with custom resource definitions, right, through which you control that operator.
Yeah,
Actually,
exactly.
You control it
yeah.
not through custom resource definition, but custom resources, which are instances of the definition, right?
Yeah, I don't remember from which Kubernetes version CRDs have been introduced, because starting from, there are so many releases out there. But custom resource definition was V1 beta 1, then it has been promoted to GA, so now it's V1. And with CRDs, essentially what you can do is a sort of define the OpenAPI v3 specification of your instance. So you're writing the scheme, and this scheme is going to be installed on the Kubernetes API server. So you don't need to reconfigure or recompile Kubernetes itself. It's a way to inject your own server specification directly on Kubernetes. And starting from that, you can define types. And you can define two kinds of types. Namespaced resources and cluster scoped resources. So in such way, you can say, I want to define a database object, and a database object is going to live into a specific namespace, and I'm going to operate that using the operators. So I say, let's say I want to create a database with 3 instances with a storage of 20 gigabyte, and the operator is doing all the hard job on your behalf. So you don't need to do anything at all. Keep in mind that obviously it's pretty similar to what we could do with Helm or with Customize, or even with templates based on Bash, okay, msubs that you could do on your behalf. The real benefit is that since your object is going to be tracked by Kubernetes itself, you are going to take full advantage of the operator pattern. So it means that there is a watcher that is going to watch resources, and when the resources are going to be deleted, updated, or modified by someone else, the operator is going to detect those changes, and it's going to perform the reconciliation. So another buzzword while we are talking about operators is the fact that you are going to declare anything, so it's not imperative. You're not launching commands to create your instances. There is the Kubernetes operator, Kubernetes itself, that is watching and performing the actions on your behalf, without checking if the action is idempotent or not. So essentially, it's like automating the dull stuff. You're ending up with a 10 per productivity, I'd say.
So when you say it's similar to Helm, I'm guessing you mean it's similar as if you would be executing Helm yourself every few minutes, kind of Helm update, Helm update, Helm update, right?
Helm update, yeah, absolutely. Keep in mind that obviously there are several tools out there, and one of the most used tools is Operator SDK, that has been developed initially, if I recall correctly, by Red Hat, and it's widely used by the Red Hat ecosystem. And you can create multiple operators. There are the Ansible operators, there are the Go operators, so you can scaffold your project. And the difference is the fact that the operator got multiple level of reactiveness. I mean that you can create the operator concept, so Helm is installing your release, but obviously you need something that is watching the changes on your Kubernetes cluster in order to react. So with that said, you can create different layers of operators that are just bootstrapping stuff, as Helm will do, or rather you can create your binary that is interacting with the Kubernetes API server and is performing constantly the reconciliation.
Okay, let's see whether we have any questions. There's one from Miroslav. What framework exists in the market? I will assume that Miroslav, and Miroslav, correct me if I'm wrong, I will assume that you mean operator type of framework or something similar. And what can be used and when? You already mentioned the operator framework. That's the one probably most people know.
Yeah, there are plenty out there, and even you can try to build your own, because in the end, it's just a way to orchestrate the Kubernetes resources. I'm a Go software engineer, so I'm really addicted to the Go programming language. and the most used one is KubeBuilder. But I just need to state a big warning, because KubeBuilder is a way to scaffold a project. It's a framework. So with KubeBuilder, you're ending up with a CLI, and with this CLI, you can generate an API type that is going to generate the custom results definition that is going to be installed on the Kubernetes API server. You can define the webhooks. You can do all the silly stuff, all the challenging stuff, because it's repetitive. It's just a scaffolder. And KubeBuilder is pretty similar to Operator SDK, and Operator SDK started embedding KubeBuilder itself. So it doesn't matter in the end, because it's just a way on how to orchestrate your project, the project layout that you would like to use. So I'd say that you could use KubeBuilder. You could use also Operator SDK, and there are other frameworks. I'm thinking about Kubernetes Operator Programming Framework, something like that. But it's on Python. I don't like Python so much. But there are also another project that I never had the time to use that should be Kudo, Kubernetes Universal Declarative Operator, or something like that. So in the end, it's just a way, just a way to scaffold your project. Keep in mind that in the underlying internals, what we are going to do is to create. I don't want to get too much technical. Victor, stop me, because otherwise I could talk for hours about that. You're going to get some watchers, some objects that are attaching to the API server, and when they are getting the events directly from the API server, are creating a reconcile request. And this reconcile request is going to be the trigger that is going to start the reconciliation. So they are saying, okay, I need to reconcile the instance test. So I need to check the deployment, the secret, all my resources, and I'm ending up the reconciliation with a reconcile result. So it has been created, it has been deleted, it has been updated, just the status, or maybe the error. So if I got the error, I can re-enqueue back the request. So essentially, I'm ending up in a sort of loop until I got my desired state.
Let's go to the next one. From Narubi, River Lione. Oh, I love the last name. If you, that must be your countryman, no? If you need one instance of the thing, isn't it easier to use a Helm chart instead of an operator, right? The answer is probably yes. If you have only one something, right?
Well, yes, but it really depends, I always say, to demonstrate my seniority, it really depends. But yeah, it's like having also that kind of question, something like, do I need multi-cluster, or I just need a single cluster? But who knows? Also because in 2023, it's pretty common having multiple clusters. So if you're sure that you just need a single thing, yeah, you can avoid that. Maybe.
There is also a certain misconception, I believe, for some, that people might think that, hey, operators are only something that I build. And realistically, almost every Kubernetes cluster has operators running over there. When you install third-party applications, there is a strong chance that they're based one way or another, not necessarily on the operator pattern, but that they are extending Kubernetes through CRDs, that they're having controllers, their own, that are watching the API and all this stuff, right? I'm not sure what's the exact difference, but are essentially doing operations inside of the cluster and extending the API and so on and so forth. So to me, the question is whether you should build your own, but whether you should use an operator, you're using it. No, I mean, databases, for example, are almost all based on operators today, because simply you cannot manage a database in Kubernetes just by saying, hey, here's a stateful set, go.
No, would be great. But keep in mind that also there is a popular project named Cert Manager, and Cert Manager essentially is an operator because you got the customer source definition like certificate, the signing request, and so on and so forth. So yeah, that's an operator, and you're using that in production.
Exactly. So everybody, in other words, everybody's using operators, but not everybody's building their own operators, right?
Yeah, unfortunately, I'd say, but it really depends, honestly.
But here's the thing, at least my perspective, right? If you have something relatively simple that you say, hey, I do not want to go through all the fuss of creating operator by myself, which we can debate whether it's a good line of thinking or no. And I'm assuming that in that case, we're talking about KubeBuilder or something like that. But there are a bunch of operators that are easier to use, not necessarily that powerful, right? You can use MetaController, and you're finished in like I want to say 15 minutes, but that excluding a bit of learning, and you're done very fast, right? Not 15 minutes, but very fast, right? If you use Crossplay in my project, you're essentially running operators. You're defining your own custom resources with their controllers and what's or not. So again, you might be using them yourself without knowing, I would say. And I do believe, and correct me, I would like to hear your opinion on that one. I do believe that more and more things will be moving away from laptops into cluster, kind of like more and more we will have, hey, instead of a complicated complicated Helm chart, here's a single resource that you define. You can define it as YAML. You do not need a Helm chart anymore because the stuff is happening over there.
You know what? Unfortunately, I cannot say something because I got some NDAs assigned. So I'll try to abstract everything. Okay. So I know a company that built a sort of meta operator. Okay. And they are managing really complex stuff. And they started wrapping everything around Helm. So Helm is nice because you are able to deploy everything on any Kubernetes cluster, and it's pretty straightforward. Helm upgrade, install, Helm remove. I don't remember. It should be remove and install. I don't remember. I need to Google that. But yeah, so far so good. But the real problem is the fact that if you need to operate that, it's going to be a mess. And with operate, I'm not saying I need to update a value. Let's take the example of the database. I need to migrate to a bigger storage. I need to migrate to a different version. That's the operation. That's why we are getting paid as site arbit engineer, because we are doing that kind of stuff. Okay. And if you're embedding all the logic into Helm, my gosh, it's really terrible.
I mean, I'm not sure even how would you embed the logic into Helm that would,
There is people that is able to do that with jobs, cron jobs, conditions.
okay, yeah, but oh man, no, no, I don't want to go
You know
there
what?
again.
You know what? It's going to be considered really, really opinionated, and it's a nice way to say a bad thing. It's opinionated, yeah.
Okay, let's go to the next one. From Michael, what do you think is appropriate to have one application per cluster instead of multiple applications per cluster? My quick comment, and I will let you answer, is that you're gonna go bankrupt very soon if you have many applications.
Oh, yeah. But honestly, so the idea is to say one application per cluster instead of multiple applications per cluster. I'm missing a bit of context here. So
No, definitely, but think of it this way. If you want to have a cluster that is serious, I mean, highly available, what's or not, you need 3 master nodes, right? If you want to make it highly available. You cannot go with 1 node because it fails, you're doomed. That means that you have 3 nodes without the nodes serving the applications for every application. Let's say it's not a big application. That would be 4 nodes, 4 servers for one application.
you know what? Yeah. Now I understand. And we created a way of saying, and that's the Kubernetes tax. The control plane, managing control plane is a tax because you're ending up with virtual instances, so virtual machines, and you got also not just the resources, but also the operational effort, the operational burden in managing multiple clusters. So it really depends. I'd say that in some circumstances, you need multiple clusters because maybe you got strict requirements, especially in enterprise world. Customers are demanding to get their your application to run on their premises or maybe on their environment in their cloud. So in such case, yeah. But keep in mind that it really depends. I don't want to answer all the questions in it depends. But I think that we've been too much used to say we can create multiple clusters. In some circumstances, maybe you can use just a single cluster. Also because the availability is offered by Kubernetes itself. You got the control plane, it's deployed on its free instances, deployed on maybe on free availability zones. So why do you need multiple clusters?
Okay, let's see the next one. Is there an operator for ChatGPT? Not that I know.
We can
I don't
ask
think that you can
ChatGPT.
even run it, right? It's
Sorry?
a service only, I think.
Yeah,
You cannot
it's
run it
service
in any
only.
form of way, I think. So
No. I don't know if it's closed source or open source, but yeah.
yeah, I don't know.
By the way, we can try to ask ChatGPT if it can create an operator on our behalf.
Yeah, somebody should actually ask ChatGPT for that. That's what it serves, right? Is there a place for OSBs with the availability of the operator pattern? What is OSB? Do you know?
Oh, no, I don't know. I was afraid of that, but since you asked that first, I'm really happy. Victor, I have no idea what is the OSBS. Let me Google that.
Michael, if you can clarify in the comments, we'll get back to it, okay? Is there a Python operator framework widely used? I don't use Python, and I suspect that you have also no idea because you just said that you hate Python.
Yeah, but there is COF. It should be COF, something like that.
Okay.
Kubernetes Operator Framework. Let me Google that again. Kubernetes Operator Framework. Yeah, COF. Kubernetes Operators Framework.
There is clarification from Scott that there is operator builder that makes KubeBuilder really easy for non-Go experts. Great.
Yeah. Also, in Operator SDK, if I recall correctly, there is a way to make it declarative. So essentially, instead of writing Go codes, you're writing sort of conditions, and these conditions are going to be applied. So, but yeah, honestly, if you're writing an operator, I would say that you need to take full ownership of the runtime and also of your project, because otherwise, what could go wrong?
And I feel also that it's similar, and I'm now half guessing because what I'm going to say is not my area, but I feel it's a similar situation like with data engineering, machine learning, things like that, where you can do things that are not in Python, but you would really benefit from, if that's your area, from learning Python, right? And I think that it's similar thing for Kubernetes. You can do many, and I see many projects actually that are built for Kubernetes, but in other languages. And I always think that that might not be the best choice because I feel that so many more things are available for Kubernetes in Go that learning Go is probably less of a problem than dealing with all the things missing or not being up to date or as advanced in other languages. My 2 cents.
No, I totally agree. Couldn't agree more. Yeah.
What else? Let's see. If I want to, okay, this is a cool one from Miroslav. If I want to write operator, what do I need to know about Kubernetes internal mechanism?
Absolutely, you need.
No. What?
You need to know everything. But yeah, I can share my experience so far. Okay. When I started writing the first open source operator, that is Capsule, you know what? Can I say bad words here? Shit happens.
Yeah,
okay?
go ahead. It's live, so I cannot censor you, even if I want to.
No, shit happens. It's just a way of saying. And I had some problems regarding the memory management because in the end you're ending up in creating loops because operators are essentially loops. And you need to understand also how to create efficient programming, because you are not creating just an operator to handle a single resource, okay? You're creating operators because you want to run at scale. And people cannot scale because we are humans, but technology can, okay? So it means that I'm teaching the operator, so my binary, my application, how to deal with that. So with that said, I remember that I started writing Capsule, and I had some problems with the memory management. It was more related to Go, but strictly related also to the internals of the controller runtime. Keep in mind that controller runtime is a package, is a library offered by the Kubernetes 6 that is writing a sort of framework to create controllers. And it was really interesting for me, and it helped me to write more efficient code to understand the internals. For example, in the operators, everything is cached or cached, it depends. But yeah, everything, there is a copy in your memory. And having everything in memory means that if your operator is handling thousands of resources, you need to be sure that you have enough memory. So sometimes also you need to say, I don't want to get the cached copy of an object. I need the real object for some reasons. So it means that you need to understand also how to optimize that, because writing an operator, everybody can do that, okay? Writing operators that scale is much more different. So I'd say that you need to understand better the runtime that you're using, in my case, Go, and also the internals. So trying to understand how the cache is working. For example, it's a never-ending phase, because every day I'm learning something new, especially regarding Kubernetes. For example, I discovered that the unstructured objects in the controller runtime are not cached by default. So what I was doing is to create different clients, one for the typed and one for the unstructured. So the types that I don't have the type in my Go runtime to decode and undecode. And a maintainer from Capsule, Max Fedotov, said to me, "Oh, you just need to pass this parameter and we are going to get the cache. We don't need to get multiple clients," and so on and so forth. So long story made short, you need to understand everything if you want to create production grade operators. I'm not saying that if it's just for internal use, you can shrug. No, absolutely. But, if you're rebuilding software, it must be production grade and reliable.
Okay, what else? Hey, Scott, long time no see. Any thoughts on Metacontroller? Well, let me give my 2 cents first. I think it's awesome, but it doesn't replace really the ones that Dario was speaking about. I think it's a different use case. It's a simpler kind of. I feel like it's almost like for people who want to create a controllers fast. Because here this is easy. Controllers can be a bit complicated for a good reason. But if you want something fast, sounds like a good option. I don't know. I'm not sure what's your experience with it though.
Honestly, I never used Metacontroller, but I think that we should also try to share my perspective regarding the difference between controller and operators. Because
Yep.
some people say, okay, operators are just controllers. Well, yes, but actually no, like the meme. But the controller, actually, on Kubernetes, we got plenty of controllers, because we got the pod controller, the service controller, and point slice controller. So all these components are watching a Kubernetes API, a default one, and doing some stuff. An example, if I create a service and the service is selecting some pods, I'm going to have the endpoint slice controller that is extracting the pod's IPs and creating or updating the endpoint slice object. So this is a controller because it's taking an object, a Kubernetes object, and is doing something related to Kubernetes. So the domain is always Kubernetes. The operator, rather, is slightly different because we are taking something that is not Kubernetes native, a database. a tenant, anything else. And we are teaching Kubernetes how to translate my object that is outside of Kubernetes into Kubernetes objects. And furthermore, we are telling to the operator, or rather, we are programming the operator so the operator knows how to deal with that, how to operate that external object. Because operator just can deal with deployments, with replica sets, stateful sets, daemon sets, and so on and so forth. But obviously, Kubernetes itself doesn't know how to perform the rolling upgrade of a PostgreSQL database or a MySQL database. So every time I know that maybe I could be too much harsh, but controller is one thing, operators is another kind of stuff, another story.
Yeah, but if I understood it correctly, essentially in meta controller you do create the controller, right? But the logic inside of that meta controller can perform what you're describing as operators type of operations, right?
Yeah, absolutely. As I told you before, never use meta controller. I was just a bit nazi regarding the name because controller, meta controller, should be something
Yeah.
like meta operator maybe, because otherwise
But
people can get confused.
that's true. That's true. I mean, it is kind of. I still feel, and I might be wrong, that the lines between what a controller and operator are kind of blurred because technically the code that is running as a controller couldn't be doing operator type of operations technically, right? There's
Technically,
nothing
yeah.
preventing you really from embedding additional logic into the code of the controller.
You know what? I can provide you a further example. So I wrote once a controller that was doing a sort of automation regarding storage. Okay, on Kubernetes storage, you can use CSI, okay, container storage interface. So you're ending up with volumes and so on and so forth. But in some circumstances and in extreme scenarios, you need to get rid of these abstractions due to technical requirements that I cannot explain because otherwise we need to get another hour. So in such case, I was watching for some events and I was going to create some operations to the underlying storage. That wasn't an operator, but rather it was a controller because I was acting to let Kubernetes mount the volumes that my application was expecting. That was a controller. Slightly different instead, creating the operator to create, I don't know, a database, a blog, a website, or whatever it is.
Okay. So when you said the external resources, you mean literally external resources, something outside
Yeah.
the cluster itself. Okay, makes sense. Uh, let's see. From Istiak, how does synchronization work with cluster autoscaler and crossplane? I guess this is more in my domain. As we know, with Argo CD in place, it will always be synchronized. I'm not sure I get the question, Istiak. I mean, cluster autoscaler will scale your cluster up and down depending on the workloads and the rules you set to be scaled. Crossplane runs in that cluster. Now, if you're referring to Crossplane creating the cluster without a scaler, then it would do just that. It would ensure that there are resources, AWS, Azure, whatever, and maybe something running in that cluster. But if you can clarify the question, unless you figured out what the question is, Dario.
No, I was just
Let's.
nodding.
Are there any notable drawbacks of using Python to write an operator versus Golang? Any subtle bugs with those not Golang SDKs that developers get hurt by later? I feel that we answered that question, but I might be wrong. You want to give it a shot, or?
Well, I just can say what I always say to customers and other people, and it's the following thing. So if you plan to write your own operator and your development team is mostly used to use Go, Java, or Python, let's use their own runtime. because Go is really good because in the end you're ending up with the types directly extracted by Kubernetes. There is no conversion at all. You can reuse a lot of utilities. And actually, I'm also doing with Capsule and also with Kamaji by Classics, but also in HAProxy Technologies, we are using a lot of libraries offered by Kubernetes itself. But I think that in the end, the operator is just the goal. What you have to do, what you have to take control is the maintainability of your operator. You cannot say, okay, I installed this operator and, oh, there is a bug, I don't know what to do. Okay. Obviously, it really depends also on the organization, on the size of the development team. But if you're running on Kubernetes or if you're running in production, you have full ownership on that. I remember that, Victor, you told us there was a sort of reel on YouTube that you were saying, you have to write your own operator. And I strongly believe that. You can write your own operator with any SDK that you prefer. Doesn't matter in the end. What you have to do is to automate the day too, because the real problem with Kubernetes is not installation, is not the setup, but it's operating on Kubernetes in the long term. And if you have the operator that is doing that on your behalf, you're saving a lot of money. And with a lot of money, I'm not referring to the resources, also the resources, but mostly people.
So it's in a way operationalizing the experience, the knowledge that you have in a way. Now, yep. Let me go back to Michael's question. You remember the one, is there a place for OSBs with the availability of the operator pattern? And I'm going back to it because he clarified it's open service broker. And I know close to nothing about open service brokers, so it's either you or we answer with no idea.
I have no idea.
Sorry, Michael.
Open service broker.
It happens.
It's really hard. I know. Open service broker. We can try to Google that in real time. Service platform interacts with service brokers. No, I have
Sometimes
no idea.
it happens to me sometimes that I have no idea. Later on, I Google it and I find out, oh yeah, I know this stuff. It just I call it differently or something like that. But no, next time. Sorry, Michael. So Rick, I just installed Harvester HCI, but notice that it doesn't seem to recognize my motherboard RAID 1 configuration. Is there a way to make Harvester recognize this RAID config? This is going to be the second one in a row. I don't use Harvester myself. I'm very cloud spoiled person. I don't know about you.
No. I got a background also from on bare metal. Using the cloud is cool. You're solving a lot of problems. Well, you're not facing so many problems, but it's really specific question. Honestly, I have no idea. No, oh my gosh, no.
Sorry. What else? From Venkata, your channel is great. Oh, thank you so much. How can I support you as a viewer? Well, that's very easy. Like the video, subscribe to the channel. If you can afford, then you can join the channel. It's price of a coffee a month. And if you work in a software company, then convince your boss to sponsor the channel. Easy. I mean, the last thing is not that easy. But liking and subscribing, that's the easy part. And yeah, joining the channel as well. What else? Let's see. From Rada, I'm learning Golang and still a beginner. Where should I start to write operator for Kubernetes? This is your domain.
Just joking. You could take a look to the code I wrote. I'm not bragging. No, I'm just joking. You shouldn't. Also because I released 2 CVEs and I'm feeling really good because, I'm not going to get recognized for the quality that I'm delivering, but rather for the CVEs that I'm going to get mentioned across the world. So yeah, jokes apart, where you can start. What I can do maybe is to share with you some really good examples. And obviously I'm not going to say Capture and Kamaji because otherwise, a conflict of interest, but you can try to take a look to the code base offered by Cloud Native PG. Cloud Native PG is really good. It has been written in Go, and also the mechanism behind cloud native PG is really cool. It's more a different context because we are not talking from the code base, but rather from the idea of running databases on Kubernetes. But that's a nice project. But furthermore, what you can do is to try to engage with the community. I strongly believe in the community, also because I'm doing open source, and open source is all about community. And what you can do is to try to join the Kubernetes operator channel on the Kubernetes Slack workspace. And pretty sure you can ask any question there and you can get some help. But mostly important, I know it's really hard, is to practice, 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 practice. Always. I learn a lot from failure in production. I know it's really hard because you're risking your job, but that's the way to try to learn everything. Unfortunately, there is no handy handbook that you have to follow all the path to get a software engineer writing operators. It's the experience. It's the pain that you can share then with the people. I can talk a lot about the pain.
Oh, yeah, pain is how you work. Failing, right?
Yeah, absolutely.
The things that happen after people start yelling at you for broken production. Whatever happens
Yeah,
after, that's the
yeah,
learning, right?
yeah, absolutely.
From Isaac, I like to introduce Kubernetes to my non-software engineer colleagues as an operating system to help lots of computers work together. Do you have a similar kind of elevator pitch for operators? I'm guessing that by operators, Isaac. I'm not sure whether when you say my non-software engineer colleagues, whether he was referring to operators or for
Maybe
operators. Okay. So now
operators.
my brain does not work. Okay, so elevator pitch is for operators. Yes, go. What's the elevator pitch?
Okay. I'll brag my open source project. So we got a project at Classics that is named Kamaji. And Kamaji is doing something really weird, I'd say, because we are running Kubernetes in Kubernetes. Okay. It's not something new. I mean, there is already some solutions out there that are doing that. But we are testing Kamaji, and with Kamaji, we are able to run up to 1,000 of clusters inside of a single installation. And the pitch can be, how many people do you need to manage 1,000 of Kubernetes installation with free virtual machines and so on and so forth? With an operator, you just need a single person, a single human to do that. Drop mic, But yeah, that's what we are saying, because in the end, operators are doing what SREs are essentially doing, operating the software. And they're doing that in a much quicker way because everything is automated. And there are no errors. Stayed in context, because if there is a bug in the operator, obviously you're going to ruin the production. But you got the test coverage. You can do whatever you want to prevent that kind of failure. Humans, they're really good, but sometimes they fail. So I think that, I don't know. Did you convince you, Victor?
Yeah, I mean it's a way to. I mean, I have a couple of other elevator pitches, right? One is more or less a variation of what you said. Operators are a way how to manage things at scale. Doesn't matter whether that's something at scale is Kubernetes cluster or anything else. It's also a way how to get rid of people. a way to fire people or a way to automate people, depending on which one you like more, right? But it's really, in my head, it's really about translating operational knowledge, the operational knowledge that you're doing potentially manually, into automated operations, right? That happen to run in Kubernetes.
And at the same time, maybe what we can add also is the fact that we are going to software define everything, because it's like also what control plane, crossplane is already doing essentially. You got everything orchestrated by Kubernetes, so the operator pattern, so we are getting the reconciliation, and then everything is software. YAML is not software, I know it's neither code, but it's just a way to codify everything. So in the end, if something is coded, you can automate that. And if you can automate that, you can save resources. A lot of saving, I'd say.
To me, that's, this applies to what I'm going to say. I feel applies equally to crossplane is what you've been talking about, operators. And that's that, in my head, Kubernetes first and foremost is a control plane to manage resources. And those resources might end up being containers running in the same cluster, right? But to me, containers are just the first implementation of that management we got in Kubernetes. But first and foremost is a control plane in my head, right? It can be containers, it can be databases somewhere else, it could be anything, really.
Anything, yeah. Keep in mind that I got a friend of mine that did a proof of concept back in 2018. And his idea was to say, we don't need to use a database and writing all the logics in the application, but rather we could use Kubernetes itself as our database. So all the business logic is going to be a custom resource definition instance. And we are touching hooks and something like that. But obviously, it's a weird project because in the end, there are some limitations also regarding Kubernetes because the size of the CRDs and so on and so forth. But yeah, you can do whatever you want.
Oh, don't tell me about. I guess that when you say size of CRDs, you meant number of CRDs. That's something that.
Yeah,
in case of the crossplane project, it makes us not sleep at night because we are constantly hitting limits. Kind of 500 CRDs, cluster breaks. Next release, improve it a bit, 1,000 CRDs, breaks again.
Yeah. Also, the problem I discovered on internal that it was really easy to understand, but when you start writing stuff, you have the time also to dig up some really nice internals. And I discovered, for example, that all the custom resource definitions are going to be stored in etcd or in the data store as plain JSON. So they are not going to be marshaled into the protobuf. So they are not optimized. They are consuming a lot of space in etcd. So if you got a lot of resources and these resources are also fat, so you got a lot of you got plenty of fields, you could have some problems. And there is a solution, by the way, don't worry. And the solution is to extend the API server, but that's a different topic because operators are running in Kubernetes and are using the same data store. So you got the etcd of the control plane, and your instances are going to be stored in the etcd of the control plane. With the API extension, instead, you can specify a different data store. So you can store all the data into a MySQL, PostgreSQL, Cassandra, or whatever you want. So in that case, you can really extend Kubernetes server. It's slightly different, by the way. It's more complicated, but it's doable. It can be done.
From Miroslav, when should you consider to switch from Helm template or templates to operator for an app? Is there any rule of thumb in complexity of templates, or just when you need to do more operations on the app than just template? Before you answer or say anything, let me just modify this, and we can fight over this if you want. To me, it's kind of really the question: when will you convert your whatever you're running into a custom resource definition, and then let the cluster process that custom resources based on that definition and do something with it? Whether that's creating additional resources, services, deployments, stateful sets in your Kubernetes cluster, whether it will do operations outside of the cluster. So in my head, the question is not necessarily only for operators, but the way I interpret it, when should you create custom resources? I don't know whether that makes sense.
Yeah, it makes sense. Yeah, absolutely. When you get burnout. Just joking. But yeah, no. I say that the operator must be used when you have troubles in operating your software. Because if your job is just adding templating, keep it simple, stupid. Okay, because in the end, if you just need to update the image or doing something like that, you can use a template engine, because in the end, otherwise the operator will do the template engine at the Go level or the Python level. So in the end, it's much more simpler doing that with Helm, because Helm can be understood also by my children of 8.
But
The problem is operational.
I would actually slightly disagree on that one. I don't think that conceptually it makes sense. Let's imagine a developer, right? A Node.js front-end developer, whatever, right? I don't think it makes sense for the majority of people to say, not to be able to define an application. There is no concept of application in Kubernetes. But to go and say, oh, I need a service, I need a deployment, I need a virtual service, I need this, I need that, right? I would rather, for example, and this is not building your own operator, but I would rather recommend, hey, use Knative.
Yeah.
Knative, you will define 15, 20 lines of YAML of things that matter, because most of what we need to define an application really is I was about to say junk. It's not junk, but filler stuff, right? Things that matter to operators, but do not matter to majority of people. Like use Knative, for example, right? Or Kubevela. I don't know if you played with Kubevela. Kubevela allows you to say, hey, this is what matters. Because I agree, Helm is not complicated, but an average person who is not a Kubernetes expert does not really understand what's in templates directory. Kind of, what's that?
Yeah, maybe we are not talking about operators here, but rather regarding
No, not
platform
operators.
engineering.
That's why
yeah.
transformed into move it to the cluster.
I think that we are in the field of platform. So in the end, you need an abstraction that is doing all the dull stuff on your behalf. So you don't need to take care of service or ingress. You don't need to understand the annotations to get the ingress class, the right one. So maybe a sort of abstraction. And you already mentioned several projects that are doing that. And I strongly believe that, yeah, it's a nice way.
What else? So CRDs and operators are a pathway to kind app or kind microservice. Yes, at least. I mean, not necessarily operators. Because if that application, correct me, this is your domain much more than mine. Not necessarily operators, but CRDs, if not operators, controllers that will actually expand. You know, your application is a deployment service, virtual service, this or that, right? Something that will create and manage those resources inside of the cluster instead of on the client side. Instead of sending them all to API of Kubernetes, send kind app or kind database.
A sort of, yeah. Keep in mind that you can create your own custom resource definition, and that custom resource definition couldn't be consumed by any operator. So it's pretty straightforward. You can define the Open API with free specification, you upload it, you wait to get it applied in the API server, and you can create any instance. So you could even use that as sort of configuration management. You know, instead of using the config map, you can create the resource, and then you're getting, deleting, updating that resource.
Exactly.
Yeah. There is no need to put in place also the automations. Absolutely.
It's kind of like server-side templating in a way.
A sort of, yeah, sort of. You know what? In the end, the real benefit of the operators is the fact that you got the constant reconciliation. If your resource doesn't have any kind of reconciliation, it's just a way to store data with a strong typing, because otherwise you will use a config map. And using a config map is not really convenient because you can put a number, a float 42 instead of string, you know, YAML problem.
There is one more big problem with using config map or something like that. It's not discoverable. Meaning you cannot. So you cannot. Kube API will not tell you when you do something silly. You cannot kind of say, give me the schema and maybe auto-generate some UI that will show it and so on and so forth, right? And as you said, operators, controllers, that might be a different story, but CRD, that's easy. Everybody can create a CRD. That's just YAML schema, nothing else.
Yeah, it's the evolution of Swagger. It's open API, so all the
Exactly.
developers are able to write definitions. So you could do that on Kubernetes itself.
Okay, a few more minutes left. Time for one more question. If somebody wants to type very, 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 very fast. Otherwise, I'm going to count to 5 for one more question. 1, 2, 3, 4, 5.
You need to wait more.
No,
They are
I'm
not
not
so
patient,
big.
huh? I'm not patient, you're saying, huh? There is always next week if I'm not traveling. Dario, thank you so much for being a guest. Any parting words, any words of wisdom before we leave and stop the stream?
I didn't get the question. Sorry.
Any
bad.
parting words, last words, words of wisdom before we stop the stream?
Stop writing operators. No, just joking. No. No. Write operators. Yeah, and play with that.
Okay, thank you everyone for joining. See you next week, probably.
Bye.
Cheers.
Ciao a tutti.
Ciao a tutti. Oh, I like Italian sounds so cool, man.
Yeah, ciao a tutti. This way with the end.
Yeah, now it's Italian. Without this,
Now
it's
it's
not Italian.
Yeah.
Now it's
See
Italian.
you later, guys. Yeah.
Cheers.
Cheers. Bye.